Hi everyone, welcome to the fundamental tutorial of DC Suite. In this video, you can learn how to use the tools of Create Pocket Scene, Create Patch Scene, and the introduction of each panel simulation mode in DC Suite to help the simulation process become faster and better. In addition to the above sessions, it also includes how to set buttons, stitches, and buttonholes to help improve the integrity of 3D garments. Furthermore, at the end of this video, I will also quickly introduce about the TG3D collection of trims provided on the Scanatic for Fashion website, so that you can quickly apply high-quality trims to your design project for further enhancing the refinement of the 3D garment after uploading it. Before you open the Scanatic DC Suite, note that right-click on it and choose to open it with high-performance NVIDIA processor to make sure you can see the most correct rendering results in the 3D window. Okay, let's get started on today's learning journey. I'm going to use this DC Project Stadium jacket as a demonstration for today's learning course. After opening it, you can find that the Placket front of this jacket hasn't been simulated yet. Press the right key on the 2D window to pull out the front line and select the front body panels of this jacket to zoom in it. Then, we need to set the position of the first button on the Placket front first. Go to the toolbar at the top of the 2D window and click Point, Create X Division Point, and follow the operation prompts next to the mouse. First, select 2 points between which an X division point needs to be created. Next, click to create the X division point. There are 2 ways you can choose. One is clicking the left key directly on the distance you want. The other is clicking the right key and inputting the value you want directly in the distance field. Here, I want to set the position of the first button 2 cm down from the top. After that, we have to set the positions of the other buttons on the Placket front. Go to the toolbar again and choose Point, Create End Division Point. Select 2 points which end division points need to be created. And also, for this step, click to increase N. There are 2 ways you can choose. One is clicking the left key 1 time at a time until the result is what you want. The other is clicking the right key and inputting the value you want directly in the number of division field, and then press Enter to finalize it. I'm going to divide the distance into 6 equal parts here. Now, we have completed the position settings of the buttons on the Placket front. Let's go to the 2D menu of Panel. Click Create Interior Point. Follow the prompts to select the panel you want to create interior points on. Select the points where we want to put the buttons and then press Enter to confirm the selections. So far, we have finished the button settings on one side, and then we have to finish the button settings on the other side. Change the select mode to Translate, and select the other front panel of the jacket. Note that the snap mode should be turned on before moving the panel until the Placket fronts of the 2 panels completely overlap. Go to the 2D menu panel and click Create Interior Point again. Select the left front panel and choose the button points we created before, and then press Enter. At this time, when you separate the 2 panels, you will find that the button points have been set already. Next, we are going to stitch up each set of buttons. Note that only enable point selection before selecting all the button points we just set. And go to Property Editor, Attribute, Triangulation, 3D Activate, and change it to Yes. You can check to show the point view in the 3D window and start to simulate it. Because establishing the simulation is synchronized between 2D and 3D windows, this step is very important to be completed before starting the simulation. After that, go to the Scene menu and choose Create Attaching Point Scene. Follow the guides to select 2 points and press Enter to create an attaching scene between the 2 interior points. Further, set up raster length under the Attaching Parameters field in the Attribute tab. The setting value of raster length is the sum of the 2 panel thickness divided by 2. So I will set 0.15 cm here. Then repeat the same action to complete the attaching point scene setting on the other buttons. After completing the settings, click Static Play in the menu at the top of the 3D window to complete the simulation of the Placket front. When you think the simulation is good enough, you can click Pause to stop the simulation. So far, we have finished sewing the Placket front of the jacket. As for how to put the button textures on our 3D garment, I will demonstrate with other trims later in today's learning course. Now, we are going to simulate pockets. As I mentioned before, since the simulation of 2D and 3D window is generated synchronously, it is necessary to confirm whether all the panels have been imported into the 3D window before simulating them. Because the panels of pockets haven't been imported into the 3D window yet, we need to import them first. Before you select the panels, remember to turn on the button Enable Panel Selection. Then, after selecting them, press the Sync Panels button to import the panels into the 3D window. You can see both of them are shown in the 3D window. We can set our mind at rest and get started to simulate pockets. First, please go to the 2D window of Scene, Create Pocket Scene, following the operation prompts that pop up next to the mouse. Select the control lines on the Pocket panel that expect to be seen with the main body, then press Enter to confirm it. Second, select the host panel and drag the Pocket panel to the position marked with the point. Note that turn on the Snap button first. It can help you accurately make the 2 points on the different panels completely overlap with each other. After completing the operations, you can see that the attaching scene between the Pocket panel and the main body panel has been created. Because these 2 panel thicknesses are both 0.15 cm, I set the same value in the raster length. Interactively use the Select and Rotate tools on the 3D window toolbar to move the Placket panel closer to the main body panel, helping to reduce the consumption of computer calculations during the 3D simulation process. Now, we have successfully completed the simulation of the right pocket. If you want to make the wrinkles of the pocket look more detailed, you can lower the setting value of intervertex distance. For example, If I set the intervertex distance value to 0.5 and then press static play, I will get the more refined simulation results. Regarding the details that how to calculate the value of rest length with the attached scene and the introduction of intervertex distance setting, please refer to the previous fundamental tutorial video, how to set up pattern and simulate. You can find the corresponding course link at the top right-hand corner of this video. So far, you may find that there is no Placket sewing market point on the right front body panel. Let's set it up now. Pay attention to whether the snap tool is turned on and move the left front body panel to the position where the center line overlaps with the right one. Then, select the mirror point tool in the 2D point menu to quickly complete the Placket sewing mark setting according to the operation prompts next to the mouse. After that, use the Create Placket Scene tool and repeat the previous steps to establish the sewing relationships between the right Placket panel and the right front body panel. The usage of Create Placket Scene is very similar to Create Placket Scene. As usual, we synchronize the patch panel to the 3D window. Next, go to the 2D window menu of Scene, Create Placket Scene, following the operation prompts that pop up next to the mouse. To select the patch panel, select the host panel, which the patch is expected to be stitched on it, and drag the patch panel to the 2 points where we want to simulate it and then press Enter. After that, you can see that the sewing relationships between the patch panel and the left front body panel have been created in the 3D space now. The last step, we need to set up the rest length of the attaching scene between the main body and the patch. After that, arrange the patch panel to the closer position before pressing the static play button to finish the simulation of the patch in the same way I mentioned in the last session. In this session, I will introduce each of the panel simulation modes of its use cases. You can find all the panel modes in the panel menu at the top of the 3D window. At the bottom of the menu, you can see 6 different panel simulation modes. Most of them have an on and off status, included the following modes: Deactivate, Activate panel, Freeze and Unfreeze panel, Stiffen and Unstiffen panel, Solidify and Unsolidify panel, Mode and Unmode panel, and Reset panel. Also, you can check and choose a panel mode in the menu by right-clicking on the selected panel. The order displayed in the menu also represents the display level of the panel simulation mode. On the top, the Active panel has the highest priority display level, followed by Freeze panel, and so on. The lowest display level is the Mode panel. You can see that the simulation state of the panel with a higher display level will take precedence over the state of a lower level. Each different panel simulation mode has its own function and display color. Switching the panel simulation mode during the simulation process according to the effect you expect to achieve can effectively help improve the simulation presentation of 3D garments. For example, default setting of each imported panel is Activate panel in the 3D window. You can also find the checkbox next to the active field on the panel information, which is the control option of Activate or Deactivate panel in the Attribute tab. If you change the panel mode to Deactivate panel, the panel will be displayed in yellow, and the system will think that this panel doesn't exist in this 3D window. Therefore, the simulation between the panels will be judged as non-existent and will not participate in the simulation. The function of the freeze panel is to freeze the current simulation status of the panel so that the tab will not be changed during the simulation process. However, in this status, the sewing relationship between the freeze panel and the unfreeze panel still exists, and it will affect the simulation results of other unfreeze panels. Now, we go back to simulating the Placket. Since I think the simulation results of the main body and sleeves are good enough, we need to change the panel mode of these panels to freeze panel to ensure that the appearance of the body will not be changed. As you can see, the panels in freeze panel mode are displayed in bright blue. Before pressing static play, please remember to set the mode of another Placket panel that is not currently used in the 3D space to the active panel to ensure that it will not affect the simulation results in any way. You can find that the left Placket panel and the left sleeve panel will overlap during the simulation. To avoid damage caused by collision during the simulation, I want to change the status of the sleeve panel to the Deactivate panel so that it doesn't exist in the 3D space and will not affect the simulation result of the Placket panel. After finishing the settings, press the static play button. At this time, you can find that the Placket panel directly passes through the left sleeve panels that set as the active panel, and the sewing relationship between the freeze panel of main body and the unfreeze panel of Placket still exists, and the main body hasn't been affected by the Placket and caused any changes in appearance. Now, we have completed the simulation of the Placket on the left side. Let's continue with the simulation of the right Placket. In the same way that I mentioned before, use Select and Rotate tools to move the Placket panel to a position close to the sewing line before the simulation. When moving to the ideal position, you can set the status of the Placket panel to Mode Panel, and the panel will be displayed in bright pink. Using the Mode Panel mode will memorize the position of each vertex in the current panel, so that even if there is a problem during the simulation, you can still return to the panel state you set at the moment with Mode Panel, avoiding to readjust it again. As for the purpose of Reset Panel, when you find that the results are not good enough or have some problems with the settings after the simulation, and you want to restore a specific panel to the initial state, you can select the panel you want to restore, right-click the mouse, and select Reset Panel. You can find that after pressing the Reset Panel button, the right Placket panel returned to the position and state at the time I set the Mode Panel. On the contrary, if I choose to reset the left Placket panel that hasn't been set with Mode Panel, you can see that it returns to the state it was originally imported into the 3D space. I want to introduce the function of the Stiffen Panel. After the simulation is finished, it is found that some parts of the garment are toggled or the simulated wrinkles are not beautiful enough. You can change the status of the problematic panel to Stiffen Panel, which will be displayed in red. Stiffen Panel mode will make the panel become very stiff. At this time, after pressing static play, you can find that the panel is constantly being stretched. When the panel is stretched to a certain extent, press the pause button and change the panel mode to on Stiffen Panel and rerun the static simulation. In this way, you can find that the original toggle panel problem has been solved. The last panel simulation mode function to be introduced is Solidify Panel. When the panel is set to Solidify Panel, it will be displayed in yellow-green. As you can see, its function is to maintain the current wrinkle state of the panel, so that the wrinkle of the panel will not be changed in the subsequent simulation process. In the following session, I'm going to show you how to set the button, buttonhole, and stitch on the 3D garment. At the beginning of this video, we complete the settings of the button position on the Placket front. In the Scanatic DC Suite, only interior points and interior lines can be applied to a trim map. Therefore, you must create a point or a line at first, and convert it into an interior point or line before applying the trim material map. First, we only enable point selection, and select one of the interior points in the upper panel of the Placket front. As you can see, before importing a button image, the settings here are all blank under the Sprite tab in the Property Editor. Below, the Property Editor window is the Sprite Browser window. You can find that the button and stitch tabs are included here. There are two different button images that have been pre-imported in the Button tab. If you want to choose other button images for using, you can find the Add button in the lower right-hand corner of the Sprite Browser window. Clicking it and opening the folder of button data built in the DC Suite, you can see that there are many different types of button images in here. Choose one or more of the button styles you desire and then click Open to import it into the Sprite Browser window. Select a button you want to apply on the 3D garment and then left-click the mouse to apply it to the selected interior point. After that, you can see that the button will be displayed in the both 2D and 3D window. Of course, if you find that you don't like this button style at all, you can also click the Delete button to delete it from the Sprite Browser window. After applying the button image to the interior point, we can further adjust the button-related settings in the Sprite tab, including tab, thickness, radius, color, height, offset, and rotate. Checking the drop-down menu of tab, you can see that there are three different button tabs that could be chosen: round, square, and diamond. You can decide the appropriate button tab according to the button image you choose. There are two fields under the tab. One is Smoothness to adjust the smoothness of the button contour, and the other is Roundness to adjust the roundness of the four corners of the button with the square tab. The thickness field is used to set the thickness of the button edge. The default value is 0. After inputting the button thickness value, the field color option will enable setting the button thickness color. Note that the usage of the field color is a little different from the color field. The color field is used to select the color that you want to overlay on the button image. But there are two ways to use both options. Use the eye driver to absorb the color, or left-click the mouse to enter the Select Color control window, and then select the color you want. And if you want to reset the color to the default setting, just click the reset icon next to each field. For the radius field, please input the value that is calculated by dividing the button diameter by 2 to it. The following two fields, height and offset, are used to determine the relative positional relationship between the button map and the interior point. You can see in the 3D window that the button is a bit stuck in the main body panel now. At this time, increasing the height of the button can solve this problem. The edge option under offset controls the moving distance in the horizontal direction. On the contrary, the V is used to adjust the moving distance in the vertical direction. Finally, rotate is used to adjust the angle of the button, and the trim position is used to define the button map to paste on the front or back of the panel. After we complete all the settings of the first button, just select this button point, press the shortcut key Alt+C to copy the button style. Select the other interior points and press Alt+V to paste the style, and then finish to attach all the buttons on this stadium jacket. Also, you can find the Copy Style and Paste Style option in the right-click menu. Then we go to the main body patterns in the 2D window. In addition to apply a stitch map to an interior line, you can also directly apply it to contour lines of a panel. Now, select the contour lines in the panel where you want to set a stitch. At this point, you will see that Sprite Browser has automatically jumped to the Stitch tab. Similarly, select the stitch maps you want to use from the built-in stitch data of the DC Suite and open it. By the way, buttonhole maps are also provided in the stitch data. After left-clicking on the stitch map, you can see the stitch-related settings in the Sprite tab as well. Since this suite will generate a repeating stitch map based on the stitch image you use, width and length are used to determine the proportion of the stitch appearance. Vertex distance is used to determine the distance between vertex and vertex on this stitch in 3D space. Offset is used to adjust the parallel distance between the stitch map and the line. And the following two fields, start offset and end offset, are used to control the distance between the stitch map and the two ends of the line segment. The height field here is the same as it in the button settings, to control the vertical height between the stitch map and the line in the Z direction. Also, color field is used to change the color of the current stitch map. Okay, let's try to set a buttonhole on this stadium jacket now. Basically, the buttonhole setting interface and method are the same as the stitch. First, create a line segment at the position where you want to set a buttonhole according to the desired size of the buttonhole. After converting this line segment to the interior line, select a buttonhole map from Sprite Browser to be imported and used. Next, input the width and length value you want, and the buttonhole map will be deformed according to the settings. Note that the length should be the same as the interior line. Otherwise, the buttonhole image will be repeatedly displayed in the line. Now, we have completed all the buttonhole settings. In addition to using the built-in trim maps data of DC Suite, you can also use other software tools to export an image with PNG or JPEG file and then import it to DC Suite to create your own trims. If you have subscribed to our Scanatic for Fashion website service, you can also directly apply the trims in the TG3D collection provided in our website after uploading your design projects. It provides various basic styles and colors of buttons, stitches, and buttonholes, so you don't need to spend extra time making trims and can quickly complete high-quality 3D design projects. I hope you enjoyed this video. For more tutorials, please subscribe to our YouTube channel and turn on the bell to get notifications. See you in the next video.